Welcome back to another edition of the coffee sessions here at the MLOps community. I am your host today. You can call me the Revolucionario, and I am joined by none other than Bam Bam. And Vishnu is back for another cameo, which we are probably going to start making into a regular occurrence. And the guest of honor today is Sara, who is one of the authors of this incredible book right here. You can see her name, Sara Robinson. And she is going to be talking to us about the design patterns that we encounter in this book. This book I highly recommend for anyone who is interested in MLOps. It's the team from Google that put this together. You can see it's called Machine Learning Design Patterns, and it goes into all kinds of good stuff about building models and MLOps. And Sara, thank you for being on here. Thank you for talking with us.
Thanks for having me. Super excited to be here. And I have my copy here as well.
There we go. That's it. So we've got a lot of stuff. I think we lost Bam Bam. He said, see you later. I'm not. He pieced out on us, but that's all good. So we've got a lot of stuff that we want to talk to you about today, but I think it would be worth just starting off with how you got into tech. Can you give us a little bit of that journey?
Yeah, definitely. That's kind of a long story, but I'll try to condense it. So I have a non-traditional path to tech. I didn't study computer science in college. After college, I moved to San Francisco to work at a small startup incubator. I was an analyst for them, doing a little bit of everything, kind of researching new opportunities, a bit of marketing, PR. And I started to meet a lot of developers. I didn't really realize I was super naive. When I moved to San Francisco, I didn't realize it was such a tech hub. And so I started meeting developers everywhere I went and started to think that maybe their job sounded cooler than mine. And also felt like I wanted to understand how all the stuff I used on a daily basis worked. So I started learning to code on my own. I actually applied to a programming boot camp and was rejected. And I was super bummed and kind of thought that was
Wow.
like my only path to learning how to code. And then my manager at the time encouraged me to just learn on my own. She's like, you don't have to do a boot camp. You could just learn on the side. So I did that. The community in San Francisco is great for learning how to code. I went to a bunch of meetups, told a bunch of people that I was doing this, mostly to hold myself accountable so that they would check in and ask like every few weeks, like, are you still doing it? Um, and then I decided I wanted to find a job where I could code for more of the time. So started applying for software engineering jobs, and then found a position at a small startup called Firebase, which maybe you have heard of.
We've
Um,
all heard of it now.
awesome. It's so cool to hear that because when I joined back in 2013, I would, ask for a show of hands who's heard of Firebase, and maybe two or three hands would go up. But it's pretty well known now. So they were hiring for a community manager position, and I thought it would be a great opportunity because all of their users are developers. That position kind of varies depending on what the product is. But since this was a developer-oriented product, it would give me a good opportunity to learn. So I got the job there as a community manager. The team was great and super supportive, and made sure that I had time to continue like writing code and getting better as part of my job, in addition to engaging with the developer community on like Stack Overflow, Twitter, and support. But doing that job also kind of required that I get more familiar with the product and API. So as I did that for a while, it evolved into a developer advocacy role. And then, as you may know, Google acquired Firebase back in 2014.
Yep.
6 years ago. Kind of crazy. Time flies.
Yeah.
So I stayed on the Firebase team for a bit at Google. And then in around 2015, I moved over to the cloud team, and then kind of fell into machine learning by accident, but have been doing machine learning ever since then. So there's a long answer to your question.
That's awesome. So exactly like when you were doing, I guess, the work at Firebase and then you came to the cloud and then you started doing stuff with machine learning, what were some things that jumped out at you right away with machine learning and how it is? different?
Yeah, so what really got me interested in it, when I joined the cloud advocacy team, my manager at the time, we didn't have that many advocates, and he encouraged me to just try a bunch of different products within cloud and see what interested me most. And it happened that at the time we had just launched our Vision API. We have many more ML products now, but there were just a few at the time. And I had never done anything with machine learning before. It was kind of a relatively new-ish concept at the time, at least in terms of cloud offerings. And I just was fascinated by it. And it was a little bit different than, traditional programming. In that, in traditional programming, you write code, you know exactly what you expect the inputs and outputs to be. Whereas in machine learning, you're training models, and you could write your code perfectly, like it could execute from end to end exactly as you expect, but the resulting model could be not good at all. And then you have to go back and look at the data. So it kind of adds this unknown element. And so I started by working with our machine learning APIs, and I spent about a year working with those, and we continued to launch new ones like speech and natural language and a few others like video. And as I was working on those, a lot of people that I presented to were asking, like, how do these models work under the hood? Because the APIs abstract a lot of that for you. So that got me interested in learning a bit more, going deeper in how machine learning models work, how you train models, what that all looks like under the hood. And so that got me started with learning, frameworks like TensorFlow, getting more involved in the model building process.
Excellent. That's so cool to hear, and to hear the journey. I can see Vishnu wants to ask one. I just saw him raise his hand. What do you got for us, Vishnu?
Yeah, no, I mean, that's a great journey, Sarah. I think what stands out is kind of, I think a lot of people in the community do this as well. It's how a lot of people who have come into machine learning, they come from other technologies and they bring those experiences with them, and that informs how they think about it. And your experience with the APIs, kind of sitting at a higher level and seeing how they've been used, and then kind of getting lower and lower level, it stands out as being like, a really useful way to learn the whole process. I think Jeremy Howard, Fast AI, is a big proponent of this, which is learn how to use things and then learn how they work. I'm kind of curious if you felt that was helpful for you in kind of making this transition into the machine learning realm.
Yeah, definitely. That's kind of my approach to learning anything. It doesn't work for everybody. Some people prefer to read everything before they get started at all. But I get distracted when I do that. So I just like to, get my hands dirty, get something that works, and then go back and figure out, like, okay, let's look at all the details, understand how every piece of this fits together. And I think that's a really useful approach for especially machine learning, because it's so complex. If you get hung up on the details before you get something working, it can take a lot longer to get started. And I definitely did that for a lot of the different aspects of machine learning that I've worked with over the years.
Yeah, the iterative piece is absolutely crucial. And I mean, to kind of come, back to where you are now and what you're up to. Can you tell us a little bit more about what a developer advocate role is, what you do, and what that's like?
Oh yeah, that's a great question.
Yeah, very good question. Because a lot of people aren't familiar with the role. So one way I describe it is like an external facing engineer. So as developer advocates, our job is to teach and inspire external developers, in my case, data scientists, ML engineers, developers, kind of a broad term that we use, and get them excited about the different products we have on cloud. And that's through a combination of a bunch of different activities. So it could be giving talks at events, obviously virtual this year, writing blog posts, publishing demo code on GitHub, publishing videos, tutorials, and then another important piece of the job. So all the things I just described are kind of, outward facing external advocacy. Another important part is taking feedback from external users like customers or just any developers in the field and relaying that back to the product team. Since they don't get as much like day-to-day contact with the external users, they're pretty deep in building the product. That's our team's job, is to tell them how folks in the field are using the product. Another thing we do internally for like internal advocacy is what we call friction logs. And basically, like, the first time we go through any sort of user journey with a product, or just it could be just our first time trying something that's new, We write a detailed log of our experience, what went wrong, what went well. And we try to approach it from like what we call like a zeroth user, external user using it for the first time perspective. So that's a short summary of what developer advocates do. Different companies define it differently. And the cool thing about my team is we can kind of choose how much time we want to spend on each of those activities. So there's some people that do tons of talks and events, and others focus more on maybe like online content, videos, tutorials, demos, things like that.
Sounds like
a really. Oh, go ahead. Good.
Yeah, sounds like
a fun job.
Yeah, cross-functional role. Fun job. Yeah, why don't you go ahead, David?
No, yeah, I was just gonna say that I think that's it sounds like a fun job to do. To be able just to collaborate with a lot of people. Learn from them what they're doing, and you're not just doing one thing. It sounds like you get a variety of problems and challenges you get to work on.
Yeah, that's one of my favorite parts of the job is it's never boring. One week I could be, heads down writing code, working on a demo. The next week I could be, writing a blog post to prep for a product launch. And we also get to work with a ton of cross-functional teams, as one of you mentioned. So we get to work with, of course, other advocates on developer relations, but also sales, engineering, product management. So we interface with a ton of other roles at the company.
Got it. One of the questions I have related to this notion of developer advocacy, you've done it at Firebase, at Google, and now you've been focused on machine learning, but you're really deep in the weeds. Compared to traditional software developer advocacy and traditional software communities, what stands out to you as being different, unique, or perhaps more fun about working in the machine learning realm as a developer advocate?
Yeah, that's a great question. So being a dev advocate on machine learning, I guess as with any technology, like it's constantly evolving. There's, a lot of new companies, new products, new integrations that come into play every day. I guess that may not be unique to machine learning, but machine learning is still, I would still call it like a relatively like emerging field. Maybe 10 years ago, there probably weren't very many dev advocates working in machine learning at all. So there's that aspect to it where there's always new things to learn, constantly new research in the field, new technology. So that part I really like about it because as I mentioned, when I joined the cloud team, there were very few ML products and now there's so many. So it's even, hard to keep track of them all, which is exciting. And it's been cool to see those new products come into play as like there are new needs in machine learning and more companies are adopting it.
Yeah, that's so true.
I would agree that I think it's still an emerging field as well. Like you mentioned, that's a great observation that it's only recently that we've been productionizing them and actually creating real products that, are being used at scale, facing a lot of users. And, that's like something that I think has been around maybe for traditional software for some time. But now with ML, there's like all these additional layers of complexity. But I agree with you. I'm on the same page. I think that complexity is what makes it super fun. I'm never bored. Like there's always something that I don't know. And I think that is what kind of drives the field as well, too, in some ways. The fact that there's not no one best way yet. Even in the tooling space, we hear about a lot of vendors and open source tools. Like no one person has it right. It's a joint effort of a lot of different people.
Yeah, definitely.
Yeah, and it's funny that so we were talking to one of your coworkers on, was it Thursday or Friday? I can't remember exactly when. Friday. Todd Underwood, and he's I don't know if you know him, but he recommended this book too. By the end, we asked him, "Hey, do you have any books that we should read?" And he said one of them was yours.
Oh, that's awesome! I don't know him, but I'll have to connect with him now and say thanks for the shout out.
There you go.
Shout out to Todd.
Yeah, Todd, he was great guest. And so he's like head of SRE for ML infrastructure at Google. And
wow, awesome.
Yeah, and so one thing that he said to go along with this emerging technology theme is that those of us that are doing this right now are either going to write the book on MLOps like yourself, or B, be the first ones to read it, like I guess the rest of us. And so I think it's really cool to like realize that it still is so new and it still is forming, that you don't have a place like in the other different software engineering that has been around for so long and it feels a little bit tired and outdated or whatever. It's just boring to talk about. This is by no means boring because we're still figuring out together, all of us, right?
Definitely.
So
I think that
yeah, go
I
ahead.
was just going to ask Demetrius, like the nice segue into the book is, so given how hard this space is, given how new this space is, how did you go about writing a book? Maybe the first place to start is what led you to write this book, given that, you know, it's so new and there's a lot of people involved in it.
That's a good question. So Lack had actually started, he's written, I think it was 2 O'Reilly books before this. He writes a ton of blog posts, and he had started writing a few blog posts that he realized described certain patterns in machine learning. So just common practices, and kind of outlining and summarizing them as design patterns. And design patterns isn't a new term. It's been applied to a lot of aspects of software engineering. And he wanted to find some co-authors. So he reached out to me. And actually this relates to what we were talking about ML being an emerging field. So my first thought when he reached out was like, absolutely not. I don't want to write a book. It takes too much time. And also,
No way.
won't a book like this be obsolete the moment it hits the shelves? That was my main concern.
Interesting.
But one of the great things about writing these machine learning design patterns as patterns is we're kind of like defining the structure of how you would do something rather than focusing specifically on the exact technology you should use to implement it and, you know, the specific code and syntax. We do have a lot of code samples in the book, but the goal of each pattern is to kind of like describe what we're solving in like a problem solution approach. So every pattern follows the same structure. So we define the problem, what ML challenge is this solving, how do you solve it in like higher level terms, and then we do provide examples of a few technologies that you can use to solve it, and then some alternative approaches. But by framing everything as a pattern, that kind of alleviated my concern about this being obsolete, because the patterns, I'm sure, like the specific software and tools that we talk about to implement, I'm sure those will change and maybe have already changed, but the ideas that we frame, those will be pretty consistent, you know, as time goes on and machine learning develops.
Yeah, that's such a good point. And it is like the idea is the important thing, and these tools and the way that you implement it are the secondary part. But just wrapping your head around the concept, I think that's one thing that I've been appreciating so much about the book, is helping me understand these different concepts that I hadn't thought about before, or I had only heard in passing. And then it was like, oh, okay, that's why you need it. That's what you want to use this for. All right, I see. So let's just dive into the book. Like, why did you feel like, so Lack was writing it, he came to you and he said, hey, let's do this, and you said, no, not right now, no, later. But then, like, when you're looking at it as a, you know, sorry, I lost my train of thought real fast.
That's all right. I can talk a bit more about like the process of deciding
the book
to
writing.
do it.
Yeah, exactly. That's kind of what I was hoping to go into, is like the idea of writing the book and what then came next.
Yeah, that's a great question. I'll tell a quick story. I have to credit my husband because he inspired me to write this. So I didn't respond to Lack right away, and I was just kind of sitting on the idea because it did seem like a cool opportunity. I've never written a book before, but it also seemed kind of overwhelming. So I happened to mention to my husband in passing that I had this opportunity, and he was like, "What? You have to write this book. Like, how could you say no to this opportunity?" He's also written an O'Reilly book a while ago. So that kind of made me change my perspective on it. Like, wow, I could learn a lot. I could get a lot out of this. So then I followed up and said I wanted to learn more. And then from there, it went pretty fast. That was just in January of this year, before COVID and everything. So then we have 3 authors, so Lack, myself, and Mike, in different orgs and roles at Google. So from there, Lack had written a few patterns already. I can't remember exactly how many. We decided to organize the book by, phases and solving a particular machine learning problem. So it starts with data preparation, then how you will frame a problem, then goes into different approaches and patterns for training, surveying, and then reproducibility, and then we end with responsible AI. So we framed it as in the order that you might solve a machine learning problem. And you don't have to read it from end to end. You can kind of just jump around. So if you look at the table of contents and you see, one pattern from each chapter that's more relevant to you, it's written in a way that you don't have to read it sequentially. So you can jump around. So from deciding to do it, we submitted a proposal to O'Reilly, iterated on it a bit. They were great to work with. They provided some really good technical feedback to us. And then we split up the work by pattern. So each of us took different patterns and then we cross-reviewed each other's work, obviously. And then we also had other reviewers at Google review our work once we were done.
Got it. Yeah. I think, I think we're all glad that you decided to write this book because I think it's much needed. I think
Thank you.
It's much needed. I kind of want to go into what a design pattern is and what the structure of the book like is even more because, looking at the table of contents, looking what's in there, it's clear that there's a lot of structure. I think what we're all looking for in machine learning is structure that we impose on the systems that we're trying to build and keeping them manageable. So, and, I think, some of our readers, some of our listeners, they may be familiar with, the Gang of Four book, the classic design patterns and object-oriented software book. My question to you kind of is inspired by that book. What is it that made the focus of this design patterns? And then from there, how did you actually identify specific patterns? Was it drawing from, experiences at Google specifically, or did you talk to external people throughout the process to research those patterns as well?
Yeah, that's a great question. So I would describe design patterns, at least as how we define them in our book, as just like defining a method or an approach for solving a particular type of problem. And the design patterns in the book, so what's interesting about them is I had implemented a lot of them before, but before the three of us authors chatted, I didn't really put a name to it. And I've actually heard that feedback from some people that have read the book is they'll be reading a pattern and they'll start to recognize it, but they may not have defined it as something before reading about it. And the great thing about that, I think, is that by defining it, it's easier for you to implement it again and recognize when you might want to reuse it in a different problem. So there's 30 patterns in the book. We came up with some of them. So we had in our proposal, I think we had maybe 25 or a few more. As we were writing, we realized like some didn't quite work out. We moved some around and we added some. They are based on we didn't talk to a lot of folks as we were coming up with the patterns, but they are based on our experiences, both external to Google and working with customers, just things that we've seen happen a lot in people deploying, production ML systems. And each of our roles is external facing, even though we're in different roles. So all three of us had the opportunity to meet with customers and see how they were solving real machine learning problems. So that's kind of how we came up with all of them. It was definitely an evolving process as we were working on the book.
Yeah, that makes a ton of sense. I think I like how you define the design pattern concept a lot, and that reusability is particularly crucial. You could call it a principle, you could call it a design pattern, whatever it is. It's something you recognize and you can apply in different contexts. A learning building block, just like in math or something like that. My next question.
I'll just jump in there and then I'll let you get to that question. But it also gives you a common language to speak with people about, and I think that's something that's huge too, right? Like to be able to say, point. Okay, here's what we're doing, and how you mentioned, Sarah, it's easier to implement again when you know what it is, and then you can tell someone, hey, this is what we're going for, and there's a definition there.
Yeah, definitely. That also makes it easier to abstract to different industries. So, maybe I work with one customer in finance that implemented a particular pattern. By making it more of a design pattern, abstracting it, it's easier for me to then go to maybe like a healthcare company and explain the same type of solution without having the specific domain distract from it.
Yeah, no, I think that's a great point. And thanks, Demetrios. You're totally right about that common language piece that we need. So, Sarah, who's the reader that you think is going to have this book on their shelf as a core reference? I mean, who is that person to you?
That's a great question. I think there's a number of roles that it applies to. I would say it's not meant to be an intro-level machine learning book. So we do assume some familiarity with basic machine learning terminology. We expect that maybe the person reading has implemented or played around with machine learning before. So I would say it's probably more of a maybe 200 level book in that regard. And then the audience in terms of role, I would say it applies to data scientists, machine learning engineers, maybe research scientists, and folks that are in charge of MLOps. It could apply to any of those roles, and maybe others that I'm missing too. And these patterns, I'd say it's geared towards organizations or people that are solving bigger machine learning problems. So yeah, I'd say mid-level, level 200 in terms of experience, and then a number of roles applying to people at different phases of the machine learning workflow.
I think this is a nice segue into excuse me, another set of questions that we wanted to talk about, dealing with the common challenges in ML. So, for example, our community, we frequently discuss a lot of domain-specific challenges of ML systems. Let's say, for example, natural language processing, computer vision, finance, healthcare. How would you advise readers to go about reconciling these domain-based needs and the design patterns that you may suggest or identify?
Yeah, that's a great question. In chapter 8 of the book, which is our last chapter, the summary chapter, we actually describe a few different domain-specific problems and solutions, and then we talk about all the different patterns you could possibly connect. It's kind of like a menu. So if you are working in a specific domain, yeah, you might even benefit from reading the last chapter first, just to see if any of your specific use cases are described, and then you can go back and look at all the different patterns we recommend for those. And then within each pattern, we do try to have a lot of examples. And so, those examples apply to specific industries. And we try to cover as many as we can, especially looking at, the three most common types of data, tabular, text, and image data. And by covering those, we try to touch on, as many different domains as we can. Although there are definitely some patterns that apply more to certain domains than others.
I think, yeah, one of the things that I'm just getting out of that is that we all have a lot of the same common problems. And even though there's a lot of specifics for some industry, there are common challenges that we all deal with in operationalizing machine learning. So for example, data quality is a big one, which has its own set of, practices and challenges. You have the reproducibility aspect, not just of one step, but of every aspect or every step within the pipeline. And then you have, while it's deployed in production, maintaining that, making sure that nothing's going wrong, things like data drift or outliers. And then the complexity around all of that makes it, I think, not sufficiently challenging. So yeah, in the book, I do appreciate that there's lots of concrete examples of how you would actually go about solving a problem, even if it's using some technology that may not be around in the future. I still think it's valuable to have an example of what this framework could look like, what this service could look like, so that we have an idea in the future.
Yeah, we try to jump around between a few different data sets, so we're not using the same data set for every problem in the book. And so, if someone is reading the book and wants to apply it more to their own problem, they can try to maybe think of a data set that they've worked with and sort of like in their head replace the example we talk about with that data set. I find that helps a lot when I do a lot of customer workshops. And I might be trying to teach the same thing, maybe prototyping models in notebooks. And just by switching the data set that I use as an example to the industry that the customer works in, I find it makes a huge difference. They identify with the data set so much more, even if they identify with the entire problem more, even if all I did was switch the data set. So that can help make it more relevant to whatever you're working on.
It's good teaching right there.
Absolutely. I mean, as somebody, David and I, we both work in healthcare, and I think for me, it is very challenging to after I work in an eye imaging company. It's very challenging to day by day as I'm sifting through eye images, thinking about the biology, thinking about all the distinct domain specific challenges that I need, abstracting it out, and abstracting, what at a high level and sort of a technical systems design level really matters. Doing that kind of zoom in, zoom out it can be challenging. And so I think, having these design patterns and having a teacher like you who makes an effort to kind of relate on that front is definitely very helpful.
Yeah, definitely. We actually have an example in the explainability pattern on an eye imaging model.
Oh, no way.
Yeah. Yeah.
After my own heart.
I'm super interested in that and hearing more about what you do, maybe later on. But yeah, we talk about how we have a model we reference a research paper about a model that detects diabetic retinopathy in images of eyes. And then using explainability, which is basically a technique to understand better what signals the model is using to make predictions, to highlight the pixels in the image that caused the model to predict that a particular eye scan was diseased or not diseased.
Yeah, that's a super contemporary example for me, and happy to share more. I think one of the questions that I have here, just talking to you, is, can you tell us about a time that some of the design patterns, perhaps as you learned them, as you were working through them with your co-authors, has been useful to you? Is there a time that you've been kind of able to recognize or use a design pattern to impose some structure in a spec or a discussion, or some kind of model building with some collaborators?
Yeah, definitely. So I'm going to talk a little bit about the workflow pipeline pattern. And so I wrote the first draft of this pattern. And before I had done that, I hadn't really done much at all with ML pipelines. So it was a really good excuse for me to become familiar with it, see all the technology that was out there. Because before that I had done, a lot of demos related to like prototyping models, how to deploy model versions. So all the different pieces that make up a pipeline, but I hadn't combined them all together using that pipeline format. And that's been really helpful to me ever since I wrote that pattern. I've found a lot of cases where I've needed to implement a pipeline, either, a demo for a customer, or just trying out different technologies to see, the latest ways of implementing a pipeline in the machine learning space. And that really helped me see how that pattern is useful, because there is some overhead in setting up a pipeline. It's tempting, and it's definitely easier to just say like, oh, I'm just gonna, write out all the pieces of this in a notebook, which is easier as, one developer working on a machine learning problem. But as soon as you start to scale that, it gets hard, you don't really want to share a notebook file with your team, and then ask them to run the same thing. They're not going to get the exact same output. So the pipeline pattern was super helpful to me in just finding a way for people to reliably reproduce different steps of a machine learning workflow, and then also isolate different steps so that maybe, one team can work on data ingestion and data transformation, and maybe another team is in charge of a different component of the pipeline, like serving.
I think that's a good topic to choose to write or learn about, because it strings together all the other ones too. So by the way, just another thing I noticed is that's a great way to learn something. You want to learn something, write about it, or try to, create some project around that. Actually use that thing that you're trying to teach yourself. And it's a good excuse, because you have to read all these different things. You have to try a bunch of different things. You have to ask questions. So I just wanted to highlight that that's actually one of the ways that I like to learn something. If I'm if I'm learning Golang, I'm actually going to try to build stuff with it, versus just reading and just kind of, consuming. Actually applying is where it really sticks, at least for me. But second thing I want to go ahead. Go ahead.
I would agree with that for sure. If anybody who's listening is interested in writing a book or has thought about it but was scared for whatever reason, you absolutely don't have to have all the knowledge for the book in your head before you start. Because a lot of the book, even patterns that I wrote that I had implemented and knew before, I definitely didn't know all the research that was available on a certain topic before I started writing. So you'll do a lot of reading, you'll play around and implement the pattern. So yeah, don't let it put you off if you haven't implemented something or you're not familiar with it. I think a great way is just to, force yourself to teach someone else about it.
Yeah, I think that's a great point, to say that there are a lot of people that are practitioners, maybe dealing with these challenges day to day and have some wisdom to share. Just because maybe they haven't written a book before or maybe are not that popular, it doesn't mean that they don't have something to say, something to contribute. Just a side note, that's actually something that I know me and Demetrios are very passionate about in the community of, getting the best out of not just us, the community, the people who are actually doing this work. They have a lot to share as well. And we want to get that. We want to share that knowledge. It's not just us. We don't know everything. One thing I will say that is good to see from like an author or someone that is teaching some content is that they're resourceful. They can point you to good resources to help you if you want to understand something a little bit better, to go and reference that yourself. So it's like they're enabling you to learn it as well versus just here. This is how you do something, now try it yourself.
Yeah, for sure. I think that's a really important element in teaching anything.
So
I think go ahead, Demetrios.
I was just going to say, maybe we could jump into this whole pipeline design pattern a little bit more. I know it's a big one, and you mentioned that you wrote that, so who better to talk to about it? Can we just go into it, like the idea of why you don't want to just have a Jupyter notebook and then try and give that to a team, and why it doesn't scale, and then also the importance of containerizing and trying to have steps so that you can retrain through a pipeline. Just basically breaking down what you have in the book, I think is really interesting and really useful. And some of us may know it already, but it never hurts to hear it again.
And
yeah,
maybe
for sure.
Sarah, just to focus it, because I know you have like 30 patterns. Maybe we could just focus on a couple ones. So like the workflow one is really interesting. Maybe stateless serving, batch serving, things like that. So you don't have to talk about all of them.
Yeah, definitely. We can pick and choose a few, but I can start with workflow pipeline. So yeah, I can just dive in. I can start by framing like the problem that this is solving. So I'll preface this by saying I love Jupyter notebooks. I use them every day, all the time, many different notebooks per day. Yes, shout out to Jupyter notebooks. But if you're on a big team trying to solve a production ML problem, let's say like I'm prototyping a workflow in my notebook where I ingest the data, I feed that in to train a model, and then I deploy the model. It's not necessarily going to work the same way if I just like, let's say, download that notebook and share it with even just one other person on my team, because they're then running all the things I did in a different environment. Potentially different operating system, different dependencies. They might not have all of the libraries installed that I used to run the notebook. Maybe they have a different version of the data. So there's a lot of complexities there. Chances are if I share with them, they'll run into some errors, maybe authentication even, as they try to run the same code. And machine learning, to add to that, also has an element of randomness to it. So, when you start out training a machine learning model, the model weights are initialized with random values. So unless you account for that, oops, my computer went black for a second. There, I'm back. Unless you account for that, that's going to also add another challenge that's going to make it hard to reproduce the problem. So that's where the pipeline pattern comes in really handy. And so what the pipeline pattern essentially is you define your machine learning workflow as a series of steps. And then each of those steps or components is the term that a lot of frameworks use to describe steps in a pipeline. These components, you containerize, each component is a separate container with its own dependencies. And by containerizing each step, you're making it easy for others to reliably reproduce your entire machine learning workflow. And a lot of pipeline frameworks also provide a way to track, it's called lineage tracking, just tracking the artifacts that are generated every time. So every time you execute the pipeline from end to end, that's called a run. So every run of your pipeline is going to generate new artifacts. And with by using the pipeline pattern that we describe in the book, you can track the artifacts from every run. So maybe you run the pipeline in the morning, you can see all the artifacts associated with that run, and then your colleague runs the same pipeline in the afternoon. You can isolate the artifacts between different runs. You can also set up triggers so that maybe once you're done developing your pipeline and you want to run it in production, maybe you want to trigger it to run when a certain amount of new data is available. By putting your ML workflow into a pipeline, it makes it doable to trigger the pipeline. Another good use for pipelines is defining, conditional scenarios. So maybe your pipeline runs is triggered when, let's say, like 5,000 rows of new data is available for whatever your task is. And you train a model, and you can set up a condition so that maybe your pipeline only moves to the deploy step if a certain accuracy threshold is met. So that's another really useful case for a pipeline. I think it also simplifies the process of logging and monitoring the output of each step. So in addition to tracking artifacts, you can also see, maybe where a particular step errored out. And because each step is kind of isolated, you could also maybe have different people working on different parts of the pipeline in parallel. I mentioned this a bit before. So, a person in charge of data ingestion can go write that code on their own, while the person working on the MLOps model deployment can write that code as well. And there's many different open source frameworks for building pipelines. In the example code, I use TFX, which is TensorFlow extended. You can also I use Kubeflow pipelines as the orchestration engine. But there's lots of different frameworks out there for pipelines. So I encourage folks to look at all the tools out there. We talk about a few other alternatives as well at the end of that pattern. I've just talked for a while. I'll open it up if you have any questions on workflow pipeline.
No, I thought that was really, really helpful. It's really, this is something that, we're thinking about in real time at my company, just to kind of share, we're building an FDA regulated device, and it's about how do you build the pipeline that allows you to deploy a model on a device and then make sure all these regulatory standards are met. And so I think, in fact, we are just now getting to the point of saying, okay, this problem is a pipeline, right? In terms of actually thinking about it in that way. And now we're moving towards more the implementation phase of saying, okay, what's the right tooling? Is this just a set of Python scripts now, or do we adopt the framework? And I'm curious how you think about that, right? That level of maturity and how that maturity occurs in your experience in terms of thinking about a design pattern like a pipeline.
Yeah, definitely. You also bring up a really good point that I forgot about in terms of like regulation and governance. Pipelines can also be a great way to solve for that, just because of the traceability. So you can, you're able, if you, for whatever reason, need to go back and show, when a particular training was run, or when you deployed a certain version, or what data a version was trained on. Pipelines simplify the process of going back and accounting for that. In terms of your question about when you would go from more of the development phase and then moving into the pipeline, I would say from my experience, most of the ML problems I've seen wouldn't start with a pipeline right away, because it can be a lot of overhead if you don't know yet what problem you're solving. So I wouldn't recommend just going headfirst into the pipeline pattern unless you just want to learn about pipelines, and then definitely should go read it. But first, usually for me or for folks that I've worked with, I've seen them just start prototyping in a Jupyter notebook. And then maybe they soon see that there are other folks that want to contribute to this problem. They want other people to be able to test out their model training code or deployment code. At that phase, I would say, either when you have multiple people contributing to the same project, or your project starts to take multiple steps. So maybe you're, not only handling like data pre-processing and transformation, but you're also writing model code. So yeah, I would say once your problem gets more complex, either in terms of like contributors involved or just steps in the process, that might be when it's time to start looking at transforming it into a pipeline.
I think that also just reinforces the importance of iterating, right? Starting with something simple. And, also this sounds exactly like what we talked about in that series that me and Dimitrios did about continuous training. This is article that Google put out a little while ago about, basically coming up with a maturity framework for a machine learning workflow. And one of the things that they make a point in talking about is, there's maybe a manual phase where you're doing a lot of things ad hoc, maybe in notebooks. You have a pipeline, but maybe only deployed in your dev environment. And then at later stages of maturity, you have it maybe in the prod environment. And then you have CI/CD automating a lot of those processes. So as you get more focus on your problem or the thing that you're trying to solve, then it's a good time to start thinking about automating that or making it an orchestrated experiment, not just in an experimental environment, but also in the production environment. So I think that is just something that we hear over and over and over again about iterating, because a lot of times, and I know this because I've felt this myself, that you want to do the coolest thing, right? You want to do the latest thing, use the latest technology. And while that may be valid for some things, right, using the choice tool for some problem, at other times it may not be necessary. Just like you said, additional overhead, more complexity than actually helps.
Yeah, for sure. So yeah, I would say definitely, do the research on, make sure you understand, all the different pipeline frameworks out there before you dive in and start using it. But it can definitely help simplify your problem once you've defined, what all the steps of it look like, for sure.
So one question I have kind of related to this is, I've read your book and I bring it to my company and I say, okay, I think a pipeline sounds like the right solution to our problems. How do I communicate the design pattern? How do I, let's say that, it's common. I think one of our community members, Laszlo, had a great quote that said 90% of all problems in MLOps are ML scientists writing bad code. And I was like, okay, I kind of see that, so what if there is a resistance to formalization or imposition of structure because it might prevent creativity, right? Or it might prevent iteration. What would, how might you deal with that?
Yeah, that's a great question. And I would say, a lot of these patterns, as with most things in ML or just engineering, they have pros and cons, pipelines included. And actually at the end of each pattern, we have a trade-offs and alternatives section. So, in that section, we try to highlight potential weaknesses of the pattern or other ways to implement it. And so while pipelines do, require a lot of setup, I think, long term, they make the most sense for just having a more organized way to track your machine learning project as it is deployed to production. And, one challenge that's unique to machine learning is that once you deploy a model, it's definitely not the end of the process. It's a good step, but that the accuracy continues to do well on new data, and often the type of data you're working with might change, or just like trends in the data will change. And if you have an evaluation step in your pipeline, that can be a really good way to catch model drift, which basically just means when your model is no longer fit for purpose. It could occur for a number of reasons. But I think pipelines are just a more organized way of tracking things. And I understand the resistance to it because it does require some effort to get it set up and to train people across your organization how to use, whatever framework you choose. But I think that the organizational benefits of it, just especially tracking, outweigh the cost of setting it up.
Yeah, and also being able to share some of those common components. I do know that some frameworks, like you mentioned, Kubeflow pipelines, that allow you to share and reuse components across, different domains. So if you have, like, let's say one component that downloads something from S3, that's like general, that could be used at multiple stages of the pipeline. And if you have that framework that enables you to share and reuse those things, it does make the lives of everyone easier, right? Like, oh, I don't have to write this component myself from scratch. I could just use it from this other team that wrote that up. And to be honest, I feel like we do that anyway at a lot of companies. At least it's been my experience. We build our own internal tools. We find solutions to our own problems. I think that what could be better, though, is the way that we package them and share them. Like, one common way to do it is build, let's say, package, so that, or an SDK that people could use, or an API that becomes available. But the notion of just sharing a component, like one unit of work that can be easily swapped out and added to things, I think that's quite attractive. Because it does simplify a lot of common, again, it's like a pattern right there.
Yeah, one thing you reminded me of as you were saying that I forgot to mention with the pipeline pattern is that a lot of these pipeline frameworks have a concept of both pre-built and custom components. So I think what you're referring to is custom components. Let's say somebody in your company writes a component for training a model, and then you're able to reuse that for maybe a different problem. But these frameworks also have pre-built components for some common tasks. And so in the TFX example I used TFX's BigQuery component. I think it's called BigQuery Gen. And that component lets you ingest data stored in BigQuery, our enterprise data warehouse on Google Cloud. So all you need to do is specify the query that you want it to run to ingest the data for both your training and your test set. So by using those pre-built components, you don't have to worry about writing that boilerplate code for data ingestion. It's already taken care of for you if your use case falls into one of the pre-built components that's been written. There's also some for data validation, model evaluation, model deployment. So taking advantage of those that are already built can also simplify the process of getting started with the pipeline.
So I'm wondering, because one of the things I did appreciate about the book was the trade-offs that you talked about at the end of every chapter, and how like, oh, this might not be for you. You also have to think of it this way. Like, here's some cons, as opposed to just saying like, you need this right now, right? And I was looking at the feature store design pattern, and because feature stores are like all anyone ever talks about in the community these days, and it showed like, hey, this is a great design pattern, but it can risk you like bloating your infrastructure. And so I'm wondering, it kind of goes back to that last question that Vishnu was asking, is how can we weigh out the two? When do we know when it's like, yes, we need to make the next step, or we can probably stay here? Do you have any patterns that you've seen along those lines? Like, when should we make the jump?
Yeah, that's a really good question. I would say, when I'm trying something new with ML or prototyping something, I try to start as simple as possible. In terms of like the number of features I use for a model too, I've definitely fallen for the trap of, I encounter a really interesting large data set with maybe like 30 different features, and I throw them all at a model. But then I really don't know which features are useful. Maybe the model perform better with fewer. So I would say start with like the least number of extra tools, model features as possible, and then build from there. And then once something gets hard to maintain, it also depends like how big of a team you're working on. But if you're starting out by just evaluating a problem on your own, start to think about, when it's getting unwieldy, when it would be really hard for you to like give this problem to someone else. So just imagining that maybe you're training somebody new on your team. Would it be doable for you to, in relatively simple meeting or just outlining the steps, how hard would it be for you to train them to do the same thing you're doing? If it would start to take a very long time, it's probably time to go to the next step of maybe seeing how you can streamline the process, either, by converting your ML problem to a pipeline, or maybe using a feature store so that, each new person that works on a problem at your organization isn't reinventing the wheel in terms of feature engineering. That's probably a good metric.
Nice. So it's coming to the end of our chat. I want to thank you so much for taking the time to explain all of this to us. I know Vishnu's got his hand up again. He's got one more, I think, and then we can close it out. But Sara, thank you so much for talking with us about this.
Yeah, thanks for having me. This has been a great conversation. And I'll remind folks that I think LAC is coming on your podcast in a few weeks. So if folks have patterns that I didn't get to, I think I mostly talked about workflow pipeline. Let folks know in the Slack, and then LAC can cover those patterns.
Yeah, totally. And the other thing was, I just realized somebody did ask a question in the Slack that they wanted me to ask you. We may have to go a little bit over. Do you have a hard stop right now?
No, I can talk for a few more minutes.
All right. Well, I'll let Vishnu ask his, and then I'll jump in with the last one.
Yeah, no, I mean, I think it was more of a comment going back to the point on trade-offs and alternatives. And I think, I think that I'm really happy you guys included that in the book, because I think that's so crucial when you're trying to quote unquote enforce design patterns or introduce design patterns into a technology systems, kind of pointing out to everyone involved, this is what we have now. This is what the problem is with it. If we do this, we could gain this. This is a drawback, and vice versa, right? I think that that's really important. It's something that I think a lot of engineers, continue to want to grow in. I know that myself, that I really want to continue to grow in terms of design, in terms of being able to communicate trade-offs and alternatives.
Yeah, I think that structure for each pattern was just really helpful because, no solution is perfect. It's good to evaluate, what are the potential flaws in something. And then also adhering to the same structure for every pattern made the book a bit more streamlined. Since we split up the work by pattern, we didn't want people to be able to tell, that who wrote each pattern, that there was a difference. So having that structure really helped with that, where each pattern in the book starts with problem, then goes into solution, and then trade-offs and alternatives. That's
really great. I mean, I will say that that's a very well organized table of contents that you guys have. It helps make it very digestible. Why don't you go ahead, Demetrios?
That's good to hear.
Awesome. So our last question is coming from Manoj in the community, and he's asking about the maturity of the ML tools and frameworks and what you think about them. Are we going to see the convergence of tools and frameworks soon?
That's a great question. Maybe we don't know what is he referring to, any framework in particular, or just in general,
I think it's
more
more
ML frameworks go like
Yeah.
GA stable versions?
Yeah, I think it's in general.
Got it. That makes sense. I mean, I think in the past year or so, we've started to see, a lot of more improvements and more stability in a lot of the machine learning tooling that we have available, both open source and, cloud-based machine learning tools. One example is TensorFlow. I think with TensorFlow 2, the process and learning curve for writing model code has gotten a lot better and more streamlined, at least in my experience. Writing TensorFlow 1 model code was a bit painful, but I've been really happy with all the improvements in TensorFlow 2. So I think we're starting to see that convergence now, but obviously because ML is still relatively emerging field, and some companies are just starting to embrace it and deploy production tools, we will continue to see, new problems arise, new challenges, and new tools to solve them. But that's a very good question.
Awesome. Well, thanks again, Sara. This has been a pleasure, and thank you, Vishnu, for coming on and joining us one more time. Bam, as always. What can I say about talking with you that I haven't already said? I will say this. Can we get a view of that sweater you got on?
Oh yeah, guys. So check out what Demetrios gave me for Christmas.
Oh wow, that's awesome.
It is. Let's describe it. Why don't you describe it, Demetrios?
That is a unicorn being ridden by Santa, and Santa has got a sword and Saturn above him with his sack of toys slung over his shoulder, for those that are just listening. And so then David sent me this one over. I just got it today. Oh, you can't really see it, but it is a floppy disk.
For your coffee.
Yeah, it's for my
or
coffee.
Your tea.
Oh, that's cool.
It's a coaster floppy disk. So, yep, we've been playing Secret Santa with each other.
I need to improve my holiday sweater.
Yeah, that's
so
what.
Last thing I will say, guys, for listeners, is definitely check out this book. There's a lot of great content there. Sara, if there's any other post relevant to that, we'll definitely share it we'll share any links that you have. But yeah, overall, there's been a really good opportunity to start thinking about like common problems and these solutions to them and sharing that. I think that's this. Just one last thing that I just thought of is that even though this is an emerging field and a lot is new, I feel like this book and more things that are coming out show that we're moving in the direction of maturity because we're able to consider those pros and cons, those trade-offs, those alternatives, and you can't really do that when it's like too early. But now we're actually kind of getting to that place where we can Yeah. Anyways, I just want to say that this is
and we're giving away 3 copies.
Of
this book in the community. So get into Slack and tell us your horror story of using a design pattern or your favorite moment when you implemented one of these design patterns?
I'm excited to see the answers to that. And then also I'll share a link with you all to put in the show notes. I wrote a blog post on my personal blog about just the process of deciding to write the book and what that looked like from start to finish. If folks are interested in just the publishing process and how we approached each pattern, I'll share that link.
Awesome. Thank you so much, Sarah.
So much.
Thank you.
Thanks for having me. Happy holidays.
Happy holidays.
Happy holidays, guys.